Okay, so this is the free preview of this translation tutorial. Here's the menu screen, the green button, start from the beginning. And I'm going to click really fast. Of course, you can pause, but there are play buttons. You can see the play button. So when students are ready, they just press the play button to move on to the next point. And right now we're just doing an introduction where I first review transcription, where DNA is turned into RNA. And then I introduce translation. And then I use the flow diagram here to introduce the central dogma developed by Francis Crick. And so if we review transcription before we go into translation. So in this review, the yellow is a gene, and the students are filling in their worksheet as they're reading along. I'm just clicking really quick, of course. And the students, again, they can go at their own pace. Nothing will happen until they press the play button. And so DNA is in the nucleus, ribosomes are in the cytoplasm. RNA is the in-between that takes information from the DNA of the nucleus to the ribosome. And this is the process of transcription. So let's do a quick review of transcription. There's an enzyme. I like to use scissors to illustrate the actions of enzymes. And then the students will match A's with U's and C's with G's. The first several come automatically, but then it'll stop in just a moment and ask what's next. So in this example, what's next? There's a yellow DNA T, so an A would be next. So when they click on A, it proceeds, it continues. And again, 3 or 4 are going to go in a row, and then it'll stop again. What comes next? In this case, the letter U for uracil would be next. And again, 3 or 4 more will go at a time, and eventually it'll stop and ask them what comes next. There's a G right there, so what comes next would be a C. And we're making RNA. Now this eventually is going to be messenger RNA in this example. The RNA detaches, the DNA reconnects. Now this animation does not show RNA processing where introns are removed and exons are bonded together, but it's just a nice reference to refer to it because if you have talked about this earlier in your lessons, it's a good review just to mention that it's there. And ultimately the mRNA goes to a ribosome. Now that we're going to the ribosome, we're going to shift focus to the genetic code. The ribosome wants to build a protein. And we're going to learn how to read this table here, the genetic code. The table is grouped into segments called codons. That's a codon, that's a codon, that's a codon. And so when the mRNA reaches the ribosome reads codons. Here comes the RNA we made earlier. And the ribosome will read 3 letters at a time, or a codon, one at a time. And if we find a codon, for example, CCU, that means the ribosome wants the amino acid called proline. If the ribosome reads ACA, then the ribosome wants the amino acid threonine. If the ribosome reads UGU, the ribosome wants the amino acid cysteine. So who's going to deliver? The word deliver is brought up 3 times. Who's going to deliver these amino acids? Time to introduce tRNA. There's another kind of RNA, tRNA. Here they are in the cytoplasm. Here are some amino acids, also in the cytoplasm. And tRNA will pick up the needed amino acids and deliver the amino acids to a ribosome. So maybe the codon calls for proline. Well, then tRNA will deliver proline. If the codon calls for methionine, then tRNA will deliver methionine. If the codon calls for valine, then tRNA will deliver valine. Just a little reminder, review there, where are those three amino acids going? They're going to a ribosome. So if the codon is UGU, then tRNA should deliver the amino acid called leucine. Now, I do not go into anticodons in this tutorial, and I want you to be aware of that. The reason I don't go into anticodons is because I use this tutorial as a way to introduce the topic of translation, and I don't want to overcomplicate things. So in this animation, they're taught the process of translation, but just know that anticodons are not mentioned. I save that for when we have a class discussion. Now we bring up the special codons, AUG. How does the ribosome know when to begin? Because AUG is a start codon, not just the codon for the amino acid methionine. And again, excuse me, again, there's always a worksheet. Students are filling in the worksheet as they go along. And tRNA should deliver methionine. How does the ribosome know when the process is finished? The ribosome follows the codon instructions. And there's instructions that tell the ribosome to stop the process of translation. In fact, there's actually 1, 2, and 3 codons that stop the process of translation. So this is kind of a put it all together here. Here comes the mRNA. Let's highlight the first codon, AUG. We find AUG on the chart. It's the start codon. And AUG is the codon for tRNA to deliver methionine. Can somebody please bring methionine to me? So now we see the tRNA bringing methionine. And again, just a reminder, there's nothing about anticodons in this tutorial. I have my students do this tutorial before we talk about translation as a class. And I don't want to overcomplicate things at the beginning, so that's why I did not include anticodons in this tutorial. But the tutorial does a wonderful job introducing the genetic code, mRNA, codons, tRNA. And so when we do start talking about translation in class, the good news is my students have a pretty good understanding of what most of translation is. And so then I have to spend very little time talking about what is tRNA, what are amino acids, what are codons, because the tutorial did a really good job of introducing them. What I spend the majority of my time talking about are the tRNA anticodons and how they fit into the sequence and how they fit into the process. And in this animation, we're just going one codon at a time. So you see U is the codon for proline. So one of these tRNAs is going to bring proline. Again, there's nothing about anticodons if you're expecting that. But I think this is a great way to introduce the topic of translation to your students. They can work at their own pace. And then when you feel like they've had a good introduction to translation, then you can talk about it with your students and bring up the one extra factor of the anticodons. So we're on the next codon, CAC. And that would be the codon for histidine. So who's going to deliver histidine? Again, a little review check for understanding. And here comes tRNA delivering histidine. And again, the students have a handout to fill in. You can see we are building a polypeptide. They find CGG on the chart, and that would be arginine. So here comes tRNA picking up an arginine and delivering it to the ribosome. And again, the students are moving at their own pace. I'm going really quick here, but the students have to, nothing proceeds until they press the play buttons that pop up at the end. And so the students are working at their own pace. They're filling out the handout as they work. And ultimately now, we've come to the stop codon, UGA. The students are shown that this is the stop, the end of the process. And we have a polypeptide, basically. Polypeptides can bond with other polypeptides to eventually make a protein. They twist and they fold and they wrap together to make a protein. Let's bring this back to the central dogma. Proteins were created through translation, and the RNA was created through transcription. Ultimately, there's a little quiz at the end. In this question, what are objects A, B, C, and D? Which object represents tRNA? That's object D. Which object represents mRNA? Object B. What represents the ribosome? Object A. What represents amino acids? The amino acid. That's C. Lots of students get this one wrong, and that's okay. I kind of want them to get this wrong because it reinforces that AUG is the start codon. What's the first amino acid? A lot of times students will look up the first three letters, CAU, and they think the answer is, I believe, histidine. And when they click on histidine, an alert pops up telling them that AUG is the start codon and that they should always start with AUG for methionine. Examine this picture. Starting with AUG, there are 10 codons. The fourth amino acid, we'll find the fourth codon. Fourth codon's GUA. Look up GUA on the chart. It's valine. I believe this is the last one. Starting with AUG, there are 10 codons. Now, there are 10 codons, yes, but the question that's going to come up is, when finished, how many amino acids incised will this polypeptide be? The answer is 9, of course, because the 10th codon is a stop codon. And then just a farewell. So I hope you found this review, this introduction, this preview helpful. And if you end up purchasing, I think you're really going to like this. I'm really proud of it. It takes my students about 45 minutes to complete this. So thanks for watching.